Hi there and welcome to this video on Senior Physics on Light and Waves. In this video we're going to explore lenses. Now lenses are often made up of glass or plastic, and their result is to refract light. Now remember, as light moves from a less dense medium into a more dense medium, its speed is going to alter. As it alters, coming in at a specific angle, it's going to change the direction of the light. Now producing curved surfaces of these lenses will allow us to cause the light to either spread out or to bend inwards, to diverge or to converge. Now this is very useful in optics, which allows us to produce different positions for our images. So let's have a look and see what type of lenses we've got. Well, the first lens we're going to look at is the concave lens. Well, the concave lens bends inwards. I always try and remember it that a cave always goes into the rock, so as a result a concave lens goes into the glass or into the plastic. Now just like we did with mirrors, we always draw them with a principal axis. So we have a principal axis which goes horizontally, and the lens is represented by a vertical straight line. Remember, you don't have to draw the lens because the laws when we're doing ray diagrams take into account that we are hitting that vertical line, which is actually hitting the lens itself. Now in this video we will look at how to draw our lenses accurately, so that we can draw our ray diagrams with our lenses accurately, so we can determine the nature and position of the image. In the next video we'll then look at using formulae in order to calculate the position and nature of the image. So let's have a closer look at our concave lens here. So here's the principal axis and the lens is represented with the vertical straight line. Now if we look at the curve of the actual lens, we'll notice that it's an arc of a circle. So if I put in with the dotted green line, there's the full circle which is generated by that arc of the lens, and there's the other circle which is generated by the other arc. As a result, because we've got two circles, we now have two centres of curvature. Those two centres of curvature I'm going to label C and C dash. Now I need to know my two centres of curvature because from that I'm going to generate my focal points. Again, there are going to be two of these, and the focal point is determined by half the distance between the centre of curvature and the vertical straight line, which is going to be my lens. So here are my two focal points, F and F dash. Now they're actually given a special name, or not really a special name, but they are indicated by specific names, which allows us to actually work out which way we're going to be sending our light when we do our ray diagrams. So F is always given the term near focal point, because I'm going to put my object on the left hand side. F dash is going to be the far focal point. Okay, so let's look at the opposite of concave lens, and that's a convex lens. Now convex lens bows outwards. Again, we can place in our lines to represent our lens and our principal axis. Remember that because they bow outwards in a circular form, they're going to make up two circles. Those two circles will have their own centres of curvature, C and C dash, and as a result they're going to have their same focal points, which is going to be half the distance, F and F dash, or the near focal point and the far focal point. Okay, so that basically explains how we get our centres of curvature and focal points for each of our lenses. Now let's look at what happens when each of the lenses actually produces, or what happens to the light as it passes through. Now the first one we're going to look at is going to be our concave lens. So there's my concave lens. Light passes into the concave lens and it spreads outwards. So it moves away and it doesn't converge on the same side. As a result, we call this a diverging lens because it causes the light to spread outwards. The image is going to be formed where the refracted rays are going to converge. Now because on the right hand side they're passing outwards, it means that they must converge on the opposite side of the mirror. So we have to track back, and you can see there with the dotted yellow lines where we're tracking back from our diverging rays, and where they cross is going to be our image. Now, as a result, our image is going to be virtual because it's going to be on the same side as the object. Now, this is in directly opposite to mirrors, because if you remember, with a mirror, the virtual image is on the opposite side of the mirror, okay, because we can't basically place a screen and get the light to hit it. It's impossible. It's a trick of the mind's eye. So in this case, for concave lenses, we're going to get a virtual image which is formed on the same side as the object. Now the opposite of this obviously is our convex lens, which produces converging rays. Now converging rays, they will all meet together on the opposite side of the lens to the object. And you can see there, they're crossing there, and I is where our image is going to be placed. As a result, we can place a screen there because we've actually got actual rays hitting at that point, and as a result, we can say that our image is real. Okay, so let's see how we draw our diagrams. So first up, we're going to look at our concave lenses. So I set up the normal profile that I did with lenses, except in this case, I'm going to have my two centers of curvature and my two focal points. Now remember, it's not necessary to put in the center of curvature, it's already been given to you. If the focal point's already been given to you, the only time we put the centers of curvature in are literally to calculate where the focal point is likely to be. So in this case, I've got my object, which is my arrow, which is basically between the center of curvature, the near center of curvature, and the near focal point. So what's the first law? Well, it's just like we did with mirrors. The first law basically goes parallel to the principal axis. Now remember, because we're dealing with concave lenses, we are going to be diverging. So on the right hand side, it's going to be spreading out. Now how do I work out my angle? Well, I basically draw a line from the near focal point to the tip of the arrow, and then I draw my arrow going out as shown here. So we can see now that it's diverging. It's not going to cross on that right hand side. So for the second law, we basically go from the top of our object through the far focal point. Now I draw up a line as far as the lens. When it hits the lens, it then runs parallel with the principal axis, as you can see there. Now there is then a third line which is generated from the top of the object and goes right through the middle between the lens and the principal axis, and that's shown in green there. Now, obviously we've got no lines which are converging, so I'm going to have to start to track back. So I track back from my first law, that you can see there in yellow, and you can see it's tracking back through the near focal point, and I track back from my horizontal blue line, and you can see that the green line and the two yellow lines converge on the same side as the object, hence that is where the image is, and our image is set to be virtual. Okay, so let's have a look at convex lenses. So I start off again with my same diagram. The first law goes parallel with the principal axis, but in this case it's going to pass through the far focal point. So as it hits the lens, it's going to be bent downwards. Remembering convex lenses converge on the far side of the lens. So it's going to pass through the far focal point. For my second law, I pass from the top of the object through the near focal point and then run parallel with the principal axis. My third law goes from the top of the arrow through the center, and you can see all three lines there converge just beyond the center of curvature. Because they converge on the opposite side as the object, I can put a screen there and it's focusing my image, and as a result there's actual light there, so the image is real. Okay, well I hope you found that useful. So what I suggest you do now is to go and watch the exemplary videos that I've drawn up for you of questions that you might get and how to determine your nature of your image and its position using an accurate ray diagram. Thanks for watching, and join me again.